high-pressure reactor system fully customized control.
Hi, a very warm welcome to all user of this high-pressure reactor and membrane separation system. It has two components, namely the main reactor sister and the electrical control panel. We will eventually introduce the third component, which is the computer system for control and data recording. This reactor comprises of two parts, namely the 200 ml reactor cell and the heater unit. Inside here, there is a heater unit. Heat is conducted from the surface of reactor to the internal. Inside here, there is a heater unit. Heat is conducted from the surface of reactor to the internal. This is the pressure gauge mounted vertically and is directly measuring the reactor pressure. This is the pressure gauge mounted vertically and is directly measuring the reactor pressure. We are currently keeping the pressure constant at the bar gauge.
Connecting in series is a pressure transmitter which is measuring and recording the data. Connecting in series is a pressure transmitter which is measuring and recording the data. The gas cylinder is the pressure source. User can set the outgoing pressure to 10 bars. There is a pressure controller installed inside the control panel. The pressure controlling gas will enter the reactor cell here. The gas above the liquid will generate pressure on top of liquid surface. Hence, the liquid will be pushed out via the dip tube. High-pressure liquid will then flow into the membrane cell unit. Their pressure transmitter installed here is to measure the upstream membrane pressure. This membrane holder assembly comprises of membrane holder, membrane, gasket, etc. Control panel houses all electronic components. First, the temperature transmitter is to measure the internal reactor temperature. Next is the reactor stirring speed control unit which user to set and control the magnetic stir speed. User can set the gas flow used to control a constant reactor pressure. Next on the control panel are three pressure values, P1, P2 and P3. Which P1 corresponds to reactor pressure, P2 corresponds to upstream membrane pressure, and P3 corresponds to downstream membrane pressure. The permeate leaving the membrane is collected and its weight will be constantly measured and recorded by the weighing balance here. The weighing balance you see here is not the actual Shimadzu weighing balance. This is just a mock-up for demo purposes. Upon receiving this reactor system, you will also receive a USB which has a program that can be installed on your laptop. You will need to connect the LAN cable from laptop to the system control panel. User can set the gas flow rate in order to achieve constant pressure. Enter a gas flow rate here, say 2 liters per minute. This 2 liters per minute of gas is used to quickly achieve the desired set point for constant pressure. Once all conditions are met, i.e., constant pressure and set liquid temperature, user can then open the dip tube liquid valve to permit the membrane separation process.